Hello, folks. Hi, Gary.
Gary, hard G.
Gary, I do apologize. And hi, Steve. Where are you folks from?
Oh, I'm based in California.
I meant company, but that works as well.
MediaTek, US.
Nice to see you. Thank you. And Steve? Steve is muted. Maybe intentionally, maybe not intentionally. And Gary, it appears you're not members, so nice to have you along anyway.
We're actually members of Linux Foundation. So I don't know if I shouldn't be on this call. Let me know. I'm kind of
no. You're welcome to be. Anyone can come, whether they're members or not. It's not at all a problem. If you're interested in confidential computing specifically, and you think about becoming members, we can talk about that as well. But anyone is welcome. You don't even need to be a Linux Foundation member. So it's very great to see you here, and we're very interested to hear why you're here. So you'll have an opportunity to talk about that in a bit if you like, I'm sure.
All right.
Yeah, so I didn't mean to scare you off at all. Quite the opposite. It was a welcome. I'm the executive director of the Confidential Computing Consortium, and I come to maybe more technical meetings than I really ought to, but I'm a geek really, and so I can't stop myself. So here I am.
Yeah, understood. I saw your keynote at the summit in San Francisco a couple of months ago.
Cool. Yes, thank you.
Hi, folks. Hello, everyone. While we're waiting for people to join, I'm going to drop the meeting note doc in the chat. Go ahead and add your name as an attendee. Looks like somebody in the last week or so deleted all the links from the top of the doc. Look into getting those back so people can find their recordings and such.
Do we have when we have some from the LF on, assuming we do, which we might not, we can ask them, but they might not.
I think I see Sal.
No, well, I meant Rian really, or Ben. But you should be able to just go back to the different last version of the doc, because it's versioned, and just add them back from that's what he says.
Yeah, it looks like it was deleted on the 8th. We can wanted to check to make sure there wasn't some reason why all that was deleted as well. But.
No, they should definitely be there. Yes.
Okay.
If we're feeling very mean, we might be able to track down who deleted them, but that's
it's whoever it was wasn't logged in. It was an anonymous edit. With the way Google Docs works, if you aren't explicitly shared into a doc, and instead you're only joining through a public link, you're anonymous.
They give you a random name. Yeah, okay, fine.
Yeah.
It's time to start looking by IP address.
Okay.
It's also useful to have a timely backup of the thing, because all our notes from like 2 years and so on, so all of them are stored in just one document. And if somebody by accident or somehow of course, we can recover from history also, I think, but it's also time to think maybe then we have some timely backup of the thing so that
So,
we.
Osama, I mean, I think we have backups in two forms. One is recordings of. Do we record any of these or not?
We record all of them, and they are on the YouTube playlist.
So there's that. And there's also the fact that the Google Doc is versioned. So unless there's a huge problem with Google, which, Keith, that would never happen, right? We should be able to go back to previous versions. But it is always sensible to think about backups. I entirely agree.
While we're at it, are we now at the Jim CCC Attestation meeting, or is the CCC Attestation meeting? I think Jim is changing the title.
Oh, yes, somebody was adding their name at the top.
Whoever Jim is, thank you for taking ownership of this. As soon as I know.
Yeah.
Okay,
sorry.
so we're 5 minutes in. I think we have a little less attendance than normal, but we should probably try to get.
It's holiday time. I'm not surprised.
Yeah. So this week, I think we have a little less like technical discussion. Instead, there's a few topics that are more about the space in general. So last time, Mark had proposed a topic around the governance patterns coming from the GRC SIG. We have a number of issues that we need to make sure get triaged in the attestation meetings repository. And then also we have Mike's document around attestation business models. Is there anything else anybody would like to discuss today?
I would say that the first and the third of those are intertwined.
Yes.
So we should be aware of that for a start.
I'll put them up next to each other. Okay. So see, what other chairs do we have today? Somebody flagged a pull request as needing attention from the chairs. We share what this is.
I think we're all here today. I see Jim, Thomas, myself, you, obviously.
So I'm guessing Osama flagged this. Do you want to introduce?
Yeah, sure. So back in 2nd July meeting, we had a discussion about whether we should close this project, which has been ongoing for, I think, 1.5 years. And the conclusion was that we should add the specification documents that we were following for these specific formal models. And recently also one part of the project was about AMD, SEV, and Ante, Derek, and Peter presented their work on that. So I would like to formally close it because all the parts that were promised have been delivered. And this PR is just to say that this is completed, and we will keep checking it in the specifications from time to time. And if the need arises, we will then open it up again, either the same project or maybe as a follow-up of that, which we think that might break the properties of that we have proved. I mean, if there is some change that actually, of course, these are in the process of becoming more mature. So the specification documents keep changing. We will try to have some process of, let's say, 2 months or 3 months or something like that to keep a track of when we should actually go and check out to see if any of the properties that were proved have now with the new specifications been invalidated or the other way around. So we then need to look back into the project. The way it's done, I think that would not be in the near future. So yeah, we have incorporated the versions that were requested, that the specification documents that are included. I also added A nice tutorial by Wasan. He was here in Dresden in March, and many people from attestation expertise, Thomas, Hannes, were also here. So we had good time enjoying the nice tutorial by him. It's a 2 hours detailed tutorial with the recent improvements in ProVerif and so on. So it's a good starting point for anyone who is looking into learning the tool.
Great.
So yeah, that's my kind of summary of the changes. And I would like
And to refresh at least my memory, the scope of this project was the modeling the attestation properties of the TE itself and the kind of primitives that it exposes, and it stops before any protocols built on top of that TE.
Right.
Is that right?
That's correct. So we called it architecturally defined attestation. And in the last presentation that I gave, we have moved on towards the other 2 projects, which are incorporating the protocols and specifically the TLS protocol. And then sometime in the future, we will then add the application part. And that's where we are moving from down to the top to add different layers into the formal model. And in some of the projects, we will try to at some abstract level, combine all of the 3 to give a overall picture of the whole thing, how it maps together. And
Okay. And the desire on this project was to have 2 different TEs to make sure that the analysis wasn't too focused on one, and it chose ARM, CCA, and Intel TDX. Is that also correct?
So in reality, we propose, so the intention was to cover 3. So that was the initial proposal, which was accepted. And the guys at University of Zagreb, they already did for AMD. So and they presented, and their artifacts are also online. They're all open source. Their paper, they have already put it on archive. And I believe it's a good work. So currently, I do not see much that can be done in addition to what they have already done. And yeah, so that's and in one of the SIG meetings also they presented their work already. Yeah, so that was, now it covers the main 3 mainstream TEs for the next generation, which will be in use, like Intel TDX, ARM CCA, and AMD SEV SMP. So yeah.
Okay, so on the AMD SEV SMP, the work was done outside of this project. Does this project provide references to that so that it can be
Yes.
also
So yeah,
similarly?
it has the link to their white paper and to their artifacts.
Okay. I think it's at a good point, in my opinion, to mark it as complete, with the caveat, as you said, that it can always be reopened if the scope needs to be brought in, or if any new information comes to light that should be incorporated. Should we, as chairs, I think we normally do our voting on the issue itself. So I'll show my support here, and I will add it to the issue. If the other chairs can do the same, if you're already satisfied, or if any discussion is needed, if anybody else wants to say anything now, but we can have the discussion.
I'm good with it. I've come to the same conclusion you have, Keith.
Okay, excellent. Okay.
And
This was
I recuse myself, but I because of the involvement in the activity, but I'm surely okay with closing it.
I think that this type of vote, I wouldn't think that you would necessarily need to recuse yourself. This is like assessing whether or not we should mark it as complete, and not really furthering your own interests or any such thing. So
then it's a thumbs up for me.
okay. So I'll add my support in the pull request, and I would ask that that others do as well. And then once we have the majority, we can go ahead and close it out.
Sounds good.
All right. Excellent.
Cool. Thanks a lot.
Okay, so the next item on the agenda is, as Mike pointed out, kind of a combination of two things. The GRC created a document around governance patterns, and Mike created one about business models, both focused around attestation verifier services. I know.
So let's start with theirs, if that's all right, because theirs had a significant impact on a part of mine, which has been quite controversial.
Okay.
So the first thing I'd say is that I'm on holiday next week, and I've taken the time not to read all of the comments on my document, to let people have a bit of a go at it, and then I'm going to come back at it and have a big look at it. But the big thing about this document is that the main focus seemed to be on a use case which I had never considered, and which I tried to put into my document, and I'm not sure makes sense. And the use case, as I understand it, is that the AVS is not doing anything other than verifying the signatures. It is not doing any workload verification. And then we get into the question of what workload means. But that is my understanding of what the main use cases of this is. And if that is the case, then we need to decide whether that is ever a sensible use case. And if so, what that means. So let's just have a bit of a look at it.
I haven't read it, but from my perspective, if I understand it correctly, it's a layering thing that makes total sense to me, which is the verifier first has to trust the attestation evidence. And then perhaps it has some policy on top of that, such as, we only want to trust workload foobar, or, et cetera, et cetera. And that could be delegated to the relying party to make that decision based on verified attestation evidence or not.
So
at least
I think in principle, yes. The problem is, as who pointed this out? What's his name? I met him for lunch the other day. Guy from ARM pointed out in my document. Simon, of course, Simon Frost. I literally had lunch with him last Thursday. I could see his face. That what does it mean that even verifying the signature means that you're verifying some of what you could call a workload? Because what does the workload mean? And this is part of the problem, because what is being checked is not just a signature, and the signature includes things like firmware typically. And so where do you start and where do you stop? And
I think in my mind, there's there's at least a platform and workload. And when I hear verify signature, that to me is suggesting you're just verifying that everything in this signed set of attestation evidence was signed by a trusted signer. What these things are, such as firmware version 3, all that you've gotten to at that point is there is a platform that I trust, and it says it's running firmware version 3.
Okay, so what do we mean by trust? I mean, I hate to pull this out, but what do we mean by trust? Because as we know, this is something which is tricky, right?
Yeah. Go ahead. What do I mean by what you in the example that I was talking through here, which is what I perhaps incorrectly am thinking this document, that the scenario you're pointing out is talking about, is the simplest of simple, right? What's the first step when a verifier gets attestation evidence? You verify it's signed, perhaps, lots of signatures and, composite pieces, different signed subsets, but let's keep it simple and just say there's data and it's signed. Perhaps by some platform key, or by some key controlled by a platform like Intel SGX or TDX or SevSNP or ARM or what have you. And so the trust I meant was, I trust that this data was signed, represents what the platform owner represents a true statement as by the platform owner. So this data here, signed by an Intel SGX key ultimately, for example, is a truthful are truthful claims, or truthful statements of attested values, right? And that's it. So there's I trust the truth of the statement. It's not that I trust any of, I trust the measurements in there. It's just, I trust this is a truthful statement. I trust that this is a statement made by SGX hardware, that in some SGX hardware running firmware version 3, it's running firmware version 3. That's it.
Okay, so what we're saying is, to avoid the word trust completely, just because I think it makes it easier, that we believe that the signature is a correctly formed signature of a, and we can use the word trust here, of a trusted public key, a private key based on the public key, right?
There's in the simplest case, there's one thing you have to trust: the signer of the evidence. So you trust, if Intel says my root CA key is this, and any key signed by this root CA key, directly or indirectly, our statement are under control of the Intel hardware and firmware, then that's what you'd have to trust.
So all we're saying, the signature is good, and we have trust in the signing certificate. That's all we're saying.
Yeah, you have to trust the signing key ultimately, and it gets a little wiggly in there, as you point out, because there's a chain of you're not going to trust an individual signing. The trust statement you make is probably something like, I trust the root CA for AMD or Intel. And then the evidence is signed by a key that chains up to that CA, and some of the control and security of those keys becomes firmware, and et cetera. So it's not as straightforward as the simple model that I was talking through to begin with. And but I guess from a just working on the Microsoft Azure Attestation Service, I definitely in my head see two very kind of different uses of our verification service. One is there's relying parties that just say, I'm going to make, I just want claims I can trust. I don't want you to enforce any policy like a particular workload, or even particular, software that's perhaps under my control running on my platform, or perhaps even firmware that's should be updated in my hardware, that's up to my admins to update in time. That sometimes the downstream relying parties want to basically say, this is what I want to enforce. It's like, perhaps it's okay that firmware isn't updated for a month because I know my admin people are out on vacation, or
so specifically what we're saying is that we want to remove as many policy options from the AVS as possible. Yeah.
I'm saying there's a
use case for that.
From my
that's fine. That's fine. Yeah, there's a use case for that. Yeah. Okay.
Yeah.
I
see two very distinct, very high level use cases for the attestation service I work on. There is the relying party that says, just give me claims I can trust, and I'm responsible for making detailed decisions about, based on claim values I can trust, then I'm going to make the decision as to what values of these claims, I want to then further my application logic, such as a workload identity, or even perhaps software versions running in the platform stack, that for the confidential compute environment. And then there's other scenarios for relying parties where they say, I just, I want you to own everything about the decision. Is the evidence trusted? Plus, you own, I want you to basically be knowledgeable about trusted workload identities and you to be responsible for you being the verification service, being responsible for, things like, is the up-to-date firmware running for all the different platform components? I see both of those, use cases in the Azure Attestation service in terms of our customers.
Okay, we've got a couple of hands up. I don't know who is first. And
yeah, I just want to quickly second what Greg said, just a very quick one. I just wanted to say I agree with what you said, and especially in the context of once we add more stuff to just CPU, right? For example, GPU or NIC or whatever, this gets way more complex. And then having an external verifier service that does all of it for you, that you don't have to do it yourself, takes away for some customers or for some end users a lot of the pain, right? So exporting all of that effort and then just saying, look, I want this to be trusted, or saying more fine-grained, I want, I don't know, my GPU to be in version 5, but I don't care about the others or something like that. There's like various degrees of freedom you might want to have, but not having to deal with it yourself, I think is going to be very interesting to a lot of folks that don't want to own the code base for all of these complex processes themselves. That's just as a comment on top. So please go ahead, sorry.
Okay, I just wanted to point out, like, the way I've always viewed the attestation verifier service is really fulfilling 3 different purposes.
I'm about to copy this into my document because I like it, just so you know, as a note.
Delegation of trust. Having a different party doing the evaluation can be good for code auditing or for just various different security model purposes. The incorporation of reference values and endorsements that can be very difficult to handle in some cases at the relying party. So having a central place where those can be imported and evaluated is useful. And then just plain usability. If you're needing to handle SGX evidence, S&P evidence, TDX evidence, and TPM evidence, all at the endpoint, it becomes difficult to keep up with, and it becomes hard to change technologies as well as you're moving from TE type to TE type. And just having a easy to use like EAT token in these cases just simplifies the relying party dramatically. And I think not all use cases need all 3 of these. Some of them really just want the usability piece, and they don't want the attestation verifier to be handling making decisions around reference values and endorsements, and they'd rather do it themselves. But some do. Some want a higher level claim that says, I've evaluated the reference values and endorsements, and this looks like a valid environment to me. You can make a decision based on these other properties, like it's running this workload, but I've vouched for the fact that it's a valid environment. And then delegation of trust, I think, is obvious. But anyway, that's my take on it. And I think a lot of it comes down to those different use cases. It's different combinations of that are what they focus on.
I don't know how to put my hand up on this. I'm having problems.
It's under reactions.
Greg has. Oh, there it is. Greg's his hand up.
Yeah. Go ahead, Greg.
Yeah, thanks. Keith said delegation of trust is obvious. Unfortunately, not to me.
Okay.
I'm not saying it's incorrect. The second 2 bullets are, I'm very familiar with. The first bullet, delegation of trust. Could you? I'm confident you're highly correct here, but I would like to get a clearer understanding of where this comes into play. Perhaps just a prototypical example or something in a bit more detail might help me understand the motivation behind it.
Sure. So just to make it concrete, as an example, if it is like an Intel TDX TEE that's running, having the evaluation being done by Intel and their Intel Trust Authority may be attractive because you're not introducing a different company to do the evaluation, and you would trust that they know how to verify it properly and would be on top of their own TE. Like that would be a reason why someone
let me give you another very different example, if I may, which is if you're doing multi-party computation, where you have a bunch of mutually distrusting parties who are working together, being able to delegate that trust to someone who they can trust, a trusted third party of some type, is very attractive in that sort of use case, I think.
So with a like passport model, having a trusted third party, like you say, would be a common currency that both of the multi-party could agree on.
I guess in my experience in discussions, kind of in this vein, folks are centered on the relying party, and they're saying, how does, you know, the relying party is making the trust decision, and then it becomes
which trust
decision? The trust decision about, do I trust the attestation evidence that's presented, and the trust decision about what are the claim values that are required for me to say, okay, I'm going to do whatever I'm going to do, share my secret with you or whatever. So the relying party is evaluating attestation evidence to make a decision to do something or not. So that's what I'm calling and maybe trust is the wrong term. It's the authorization decision, whether it's going to, based on this attestation evidence, is it going to authorize and do a particular, take a particular action. And so they have to make a trust decision, or they have to make an authorization decision, and part of that is making a trust decision on, do I trust this attestation evidence? And you know, and the way that I've kind of seen this, experienced this in conversations is relying parties are, you know, they're tinfoil hat people ultimately, or you have to be ready for those kind of people. And even like in the scenario, I think, Mike, you talked about, like multiple disparate companies coming together and sharing and having kind of a third party that can be kind of the neutral, you know, trusted third party. The kind of, my conversations in this space have been kind of, you know, the relying party, they want to see the source code for the verification service, and they want it to be, you know, reproducible bills, and that's how they build trust. They don't blindly trust anybody, you know. They want to have kind of they want to be able to audit and verify the trust they place. So whether it's Microsoft running, you know, measured source code, that's the verification service, or Google or hackers.com, the trust is that they've, you know, essentially have a verified verification service that they can prove that they trust, because they can, you know, track back to the ultimate source code that's running that service.
So while that is absolutely the way I'd love the world to work, I think we need to look into the future and how we allow confidential computing to become ubiquitous. And to do that, we need to consider all the possible models. And I think absolutely one of the models of that is your regulator tells you that you're going to have to use attestation, and you choose one of these two attestation services because your regulator tells you, not because you have a chance to look through all the stuff, or, you know, you're a consumer and you're using this stuff and you're not in a position to do that, or you're, I don't know, you work in government and you're told you have to use this sort of stuff. So I don't think that's always going to be the case. So while I agree that that is nice, I think we need to start looking to beyond that to more naive users and to different sets of use cases as well. And there was something I wanted to come back to quite a long way back as well, which is what these signatures mean. Because signatures are over, the certificates associated with signatures in attestation measurements mean different things in different schemes, schemata, whatever. And where do you draw the line? Because you talked to, well, someone, I can't remember who it was, talked about platform. And for me, a platform can mean many, many different things. I would love to live in a world where we only run confidential computing aware applications, and we're nowhere near that, right? There's going to be lots of applications which are a big old VM running SQL database or Cisco or I don't know what it is, right? A big database, or just existing set of applications which you've just thrown into a VM and you run it, right? So let's look at what platform means in that context. Now let's go from the bottom up. And I'll be missing some steps, but here's some of them. We've got the chip. Okay, we all agree that needs to be trusted. There's going to be some firmware and or microcode associated with that chip. Fine. Hypervisor hopefully is outside our trust boundary. That's good. Happy about that. So we're now inside inside the TE. UEFI. We know there are lots of problems with the UEFI or BIOS. They're being addressed in a variety of ways, some of which may work, others may not, but this is a conversation we need to keep having. But that sits absolutely for me on that boundary. Then we've got the question of, do we include the Linux kernel? Do we include the Linux scheduler, which is inside that? Do we, all of the stack before the thing we actually care about, which is the classical workload in terms of what, if you're talking about, cloud workload. And so do we include the application? Do we include the what in the NARC's world would be the platform, the execution environment, but in this world is a full-blown Linux VM? Do we include the UEFI? Do we include the firmware and microcode at the bottom? Yes, presumably we include the chip. But so I'm absolutely in favor of having a workload-less attestation opportunity, right? But I don't know what workloadless looks like, and I think we need to define it as part of this work. So one of the things I'm going to be doing after I come back from holiday is splitting my document into two parts, because there's a whole bunch of technical questions that come up which are basically unrelated to the business. Well, they're slightly related. So we need to do two sets of work on that. And some of that work needs to happen in this forum here. So I think we're probably agreeing on most of this stuff, but we just need to pick down into all of these and be aware of awkwardnesses, like the ARM model for attestation will be different because it will not be ARM that is providing the keys. It'll be Fujitsu and Samsung and Ampere in places, right? So there's going to be awkwardnesses there that we need to look at. And I want to be trying to come up with as generalizable a case as possible, because this is the world that we have to build, not just the attestation SIG, right? This is broader than that. But these are the questions that I really want to be addressing so that we can help CC become ubiquitous. Rant off, and I'll shut up for a bit.
I think, Osama, you were next.
Yeah, I just wanted to also, like Greg, just have some clarification on the delegation of trust to get a better understanding of this, because even the case that Mike mentioned, like the multi-party computation, if we have a service provided by Intel, for instance, so they implicitly already trust Intel. So Intel can no way be out of that trusted computing base, because they are the hardware manufacturer, right? And I would also like to have some clarification of what exactly, or a better understanding of what exactly these certain cases are, which probably, like Greg, I'm also missing, but I really do not see why would I, even as a part, so if I'm one of the parties, I know already that I trust Intel for this, assuming that we have all agreed on, all the parties, I mean, including myself as one of the parties, I have agreed on, let's use Intel TDX for all of our computation. Let's say by some means we have agreed to trust that. So we already have Intel in our trusted computing base, right? So we cannot, if we work with confidential computing, we have to trust them. There is no way around. So the question in my mind is, why would I trust a third party to do a third party, meaning someone who I'm delegating the trust for the verification? What would be that kind of a use case?
I've got a bunch of those use cases, I think. So the first one is, as soon as you start saying these are things which are outside the very low level, which is the firmware and the chip, I don't think Intel wants to be in the business, and I don't think I want Intel to be in the business of taking all of my workloads, hashing them, managing them as I run a DevOps world, and have 10,000 different workloads a year, and managing the revocation of those and all the policy associated with each one. So as soon as you move beyond the the very low level signature verification, you need to be thinking about other parties. The other thing, there's also use cases like air-gapped or high latency use cases where you are not necessarily going to be able to trust Intel to be doing all of that themselves. Are those two good examples or not?
Yeah, I think that makes sense. That's fine. So basically you are saying that the cases that Intel currently does not provide. So ideally speaking, I think they will keep extending their services. They had previously they provided the DCAP, which were the data center attestation primitives. So they were supposed to be primitives, which one can build their own service on. So now they provide an attestation service. So what you are saying is basically other things which they do not currently provide. So I was more of assuming that ultimately they will provide more of the support for that. So,
yeah, but also for AMD and ARM and NVIDIA, do I really want them to be doing all of that? They might like me to, but I'm not sure I want to.
Right.
Yeah. And I think
you're next. Yeah.
Yeah, not all of the customers' use cases are going to be viewing these things the same.
Yeah.
Some of the customers that we talk to go back to, like Mike was talking about, the multi-party compute use case. The primary thing, like the most important thing that they care about, is the relying party not trusting the one that is configuring and running the workload.
And operating it.
Operating it. Word operating has caused some confusion in the past, but
okay, sorry.
I'm not referring to the cloud service provider here. I'm referring to like the project administrator that is running.
Oh, okay. No, I was, so that's helpful as well. Thank you.
Yeah. So like the main thing that they don't want to trust is the project administrator that is actually deploying a workload, that the code they're running is trustworthy. The cloud service provider itself is great to get out of their trust model, but it's not the top thing on their concern. And when that is the case, some of the trade-offs between like the trust delegation piece change a bit. And to Mike's point just a minute ago, that things related to like availability, high availability, and frankly cost mean that they might choose a different one, even if the attestation verifier is run by the cloud service provider itself. That is a trade-off that they make because they see just the raising the bar to requiring collusion between the part of the cloud service provider that creates the TEE and the part of the cloud service provider that runs the verifier service is enough, because their main concern is separating the trust between the relying party and the project administrator. So wanted to throw that out there. But that's not always the case. Some are absolutely.
Yeah, sure. But then the question arises that how much familiar they are with confidential computing and what exactly do they call as confidential computing? So if the promise of the confidential computing is to provide you against the the cloud service provider, then that's not really doing the confidential computing itself. So
the cloud service provider isn't like one person, right? And when we talk to customers, like some of them see it as a fairly nuanced thing, where they want to make sure that what Google, we call them SREs, but the ones that maintain the machines where the workloads run, that they can't just get access by doing them.
And presumably also whoever runs your Kubernetes instance, right? So that type of thing as well.
Yeah.
Yeah. Okay.
Yes. But it's not all just the company that is in charge of the cloud service provider. It's all one entity. Like a lot of our customers don't view it that way. So having some delegation of trust within that company is still useful.
I mean, then there is a difference between the customers, right? So I mean, what I was trying to say is that, I mean, not everyone is technically aware of all the technical details of all this trust and so on. These are technical concepts, and when we say customers, there is a category of or a wide category or a spectrum even of the customers. Then they might not be aware what actually is going on, and then yeah, so that's another debate. But I got your point.
We need to try and make it as clear as possible what these choices are, and that's very, very difficult. I think Greg's got his hand up as well. If anyone else has questions, please put your hand up.
Go ahead, Greg.
Yeah. Here's how the world looks to me. Relying parties have no choice but to delegate trust to the existing verification services. MAA, ITA, I'm not quite sure about Verizon, but they have no way to provably show, to guarantee to a relying party, this is what's happening under the covers. So they have to delegate their trust. And running one of these attestations, Keith, I see your expression. Maybe you want to clarify.
I think with the background check model, they don't have to. Like, they could get the raw evidence and evaluate themselves locally with their own reference values.
Yeah, but then what's the point of a verification service?
No, wouldn't use one. Like your relying party would itself assume the role of.
But the background check model doesn't mean that doesn't. If you run your own verifier, then you're not delegating trust. You are running your verifier in code that you control. I'm talking about the case where there's a verification service remote from your and maybe I'm got this conversation wrong here, or the whole broader context here. I
think that's right.
I thought we're talking about a circumstance where a separate verification service was hosting the verifier, and a relying party was essentially reaching out to this separate verification service, such as, for example, Intel ITA.
Yeah, I think that's the main use case. I think Keith is pointing out that AVS may be run by the first party, in which case it ceases to be an external service. But yeah.
Yeah. If the verifier is, if you're running your own verifier, that's not what. Then there is no delegation of trust. You're trusting yourself. If you're using an external verifier such as ITA, probably Verizon, Azure Attestation, all the ones I'm familiar with, you have
do you mean Verizon, right?
Verizon, yes. I'm sorry. I didn't
okay, fine. Right. Verizon being a rather different entity. Okay, I wasn't aware they operated one. Okay,
Verizon.
Fine. And of course, Verizon doesn't operate one, right? It's just a way to do it.
Yes, it's a code. But so I'll just pick on ITA, and as I understand, ITA is not open source at this point in time, or maybe I'll just pick on myself. I'll just say Azure Attestation. If you choose to use the Azure Attestation service, you at this point have no choice but to delegate trust. It's required, because we cannot prove to you yet, exactly what code we're running. We're not open source. We don't have reproducible builds, yada, yada, yada. You have to trust Microsoft and the Azure Attestation service. You have to delegate your trust. There's no choice, whether it's a feature or not. And what I experience as someone running this service is it's generally not a feature. People say, this really kind of pains me that, I'm having to trust you. Is there some way that you can more accurately, let me know exactly what's happening under the covers in a provable fashion, so I don't have to trust you?
Yeah, but that's, sorry, Greg, but this is just, an implementation detail, isn't it? Because in principle, you could provide this kind of feature on top of your verifier, right?
And then even if you do, they're not delegating trust, because they basically say, these are I trust this code that I've audited. So I'm not delegating trust anywhere.
Wrong. You're still trusting you to operate it correctly. It's a different type of trust. There are ways around this, including things like ZTP, which we can talk about.
But if it's like run in a confidential compute environment, yada, 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 then the only thing that you as the operator can do is a DOS attack, right? You can make the service not operate. You can't change the resultant values.
But you can't know that it's operating correctly unless you can prove the bootstrap process, which is extremely difficult. I'm not saying it's not doable, but it is extremely difficult. Dave Quigley was next, I think.
So with regards to trust, delegating trust to Intel Trust Authority, I don't know. So if you look at the attestation architectures, there's the ability to request basically a quote from the verifier as to what the environment that the verification was run in. And I know there are service providers who are working on providing that. So when you go to Intel Trust Authority, you could say, I would like a quote of your environment that you're verifying my results.
And to be clear, MEA has that, but the work to actually verify what's behind that quote, what's the exact source code, what does that MR signer and MR enclave mean? That's the part that's not stitched together.
Yeah, and we need to be creating a world where and a set of documents to explain how that happens, why it's important, and how to validate it. And that's part of where I want to be going with this document or documents. These are all absolutely important things, Greg. I 100% agree. Giri, I think, had his hand up as well, possibly next.
Yeah, I guess I'm wondering a little bit about the comments from Greg, the speaker from Microsoft Azure.
You're very quiet, Gary. Could you speak up, maybe? Thanks.
Yeah, okay. I was wondering about the comments on the speaker from Microsoft Azure, Greg, on establishing trust with the verifier. Particularly, I believe ITA is moving to EAT for entity attestation token for encapsulation of attestation results. So to me, that means that those are attested results. So when the results are produced to the relying party, you get the relying party also gets to verify the security state of the verifier itself. Why is that not sufficient for the relying party?
It's a bit circular, isn't it?
What do you mean it's circular? It's not. It's
I'm trusting Intel to check that they've trusted themselves, right?
Yeah, but that's the way attestation works, right? So
but
it's not necessarily a self-reporting, right? I mean, there are other things you can do. I mean, I'm the co-editor of the entity attestation token. We actually allow for carriage of third-party certification results within the attestation token itself. So
there are ways.
I think I'll Gary. Why do you trust that signing key? The EAT token is signed by signing key. Why do you trust that key?
That gets into the endorsement aspect of it. So you've seen RFC 9334, right? Pardon me, I'm turning it off. RFC 9334 does provide for endorsements and reference values from trusted third parties. We're just saying instead of just the verifier being a recipient to that, the relying party can be a recipient to that as well. So,
I think what I'm sensing here is the theory is the verifier can prove that it's trustable. I agree with that theory. I'm saying the practice in the trenches is it's not practically achievable now. And as someone running a verifier, in production, that sometimes causes some of our customers pain.
Okay, so that was kind of the crux of my question. Why did you think it was not practically achievable now?
For operational reasons, basically, or
what are the operational reasons? In other words.
I think reproducible builds, open source, and just the vast amount of code that goes into a multi-tenant, globally scalable, attestation service, like for MAA, run, essentially in every data center worldwide. It's just a massive amount of code. The verification part is a component amongst a whole bunch of other components that all are a good chunk of them would need to be measured and essentially visible to folks to verify.
Okay, so I'll just kind of comment from a semiconductor manufacturer point of view, and and I'm not going to speak for other ones on the call, but I think if we were to actually stage a verifier service similar to ITA, we would like to know from a relying party point of view, including and I consider Microsoft Azure to be relying party, not just a verifier. what exactly is required for a verification service to prove it's trustable? Because I think that's, and I think it's probably also something that would need to be incorporated in Verizon as a reference design as well.
I think it's the ability to reliably match source code to the measured running code. So if we're speaking SGX kind of language, to be able to take a given body of source code, run it through a reproducible build, produce produce a hash code that matches the MR enclave value in the measurement returned from the service that's running the code that's in question.
I don't think that's enough, but it's certainly a starting point, and I've added it to one of my questions and notes to be addressed in the documents that I'm going to be spinning off. We've only got 5 minutes left. Keith, you're the chair, right? Do you want to take us in?
I was waiting my hand to come around, and I had comments, but I was going to instead try to bring the meeting to a close. I think the discussion's coming in, active enough here at the end that I propose that we continue the discussion in the next meeting. Any of the chairs volunteer to chair that?
Okay, may I make a note as well, which is that I intend to spin off a business models attestation for business models working group. And some of the conversations will probably be better fitting there, so that we can keep, maybe more pure technical stuff in here. And I don't know what that split looks like, and I want to work with the chairs to ensure that you keep the important and interesting stuff here, but that we have good crossover between the two. So that's going to be a couple of weeks away. So that's kind of where I am with that. All right. Okay.
So may or may not be a major topic for the next meeting, but
I think it probably will be. We've got enough stuff to be getting on with, right?
Any of the other SIG chairs willing to chair the next meeting?
Yeah, I think I'll volunteer.
Okay.
Who's that?
Thanks, Jim.
Jim, yeah.
Cool. Thanks, folks.
Great. All right. Thank you.
Fun.
Yeah. This I think struck a chord with a lot of folks, so I think it's a good discussion to be having. Okay. So we have a chair for next meeting. Anybody who has additional topics that they want to discuss, and we also didn't get to our issue backlog that was on the agenda for this time, should probably be carried over to next time. But please do add topics you'd like to discuss to the meeting notes for next time, and we'll see everybody then.
Thanks, everyone. Really appreciate it. Great
Good
discussion.
Have a good couple of weeks.
Bye.
Yeah.
Bye.
Thanks. Bye.